Okay, the next section is 4.5. It deals with properties of logarithms. I would consider this one of the most important things in logarithms. Please make sure you know how to do these. Notice I wrote log without a base. That means these apply to logarithms of any base. Could be a natural logarithm, could be a logarithm base 10, could be a logarithm base. Okay, again, these work for logarithms of any property. So log of A times B can be written as log A plus log B. So the multiplication, log of a product becomes the sum of the logs. If it's division, it's log of the top minus log of the bottom. And if it's a log of A to the B power, you can pull the power out front and use B times log A. We're going to use these properties to do something like in example 2 here to expand. Now the assignment will be 4, 5, and we're going to do 3 to 49 odds. But I'm not going to start them until we go through some examples first. I want to expand example 2. I see a division. So that tells me probably this property. So I'm going to write log of the top minus log of the bottom. Notice I'm not writing the base 6. I'll put it in at the end. Now I see that I have the log of a product, the 5 times the x cubed. That's this formula. So it could be log of the 5 plus the log of the x cubed. There's only one last property to apply, and this is the last one here, where you have a power log of x to the third. That would allow me to pull the exponent out front. So log 5 plus 3 log x minus log y would be the expansion. Now don't forget, these are all log base 6. But these properties apply to logarithm no matter what the base is. That's an expand. Now I'm going to make up a condense here. 2 log x plus log y minus 3 log z. Let's see if we can condense this and go the other direction. First thing is I might take these numbers out front and put them up as exponents. So this could be log of x squared plus log of y minus log of z to the third. The addition becomes multiplication, so that's x squared y. The subtraction becomes division, so it would be log of x squared y divided by z to the third. With practice, these will become a little bit easier. That's one example of expansion, example 2, and then here's an example I made up, one where we condensed. There's another formula involving change of base. I use the one over here on the left. Log base A of B equals natural log of B over natural log of A. The formula on the right is more what they give you. They make up a base. Notice the C on the right. There's no C on the left, is there? It could work for any base. So if you don't mind, I'm going to highly recommend you just simply use this one. So here is an example in the textbook. Log base 5 of 8. Well, think about it a minute. 5 to what power is 8? Would it be 2 point something or 1 point something? 5 to the 1 is 5. That's less than 8. 5 to the 2 is 25. That's bigger than 8. I assume it's going to be 1 point something, right? So here's how you do it. You do natural log of your argument divided by natural log of your base. And that will give me what this equals. So I'm going to do natural log of 8 and divide by natural log of 5, and I get 1.292. So that's how I would change the base. Let's go ahead and do one that we know. Guys, do I know this one? Log base 3 of 9. Do you know what that is? 3 to what power is 9? 2. The answer to this is 2. But if you didn't know that, could you do natural log of 9, the argument, divided by natural log of the base? Now, some of you are going to have more advanced calculators that have log base. If you actually have a TI-84 or one of the more advanced calculators, you might want to explore log base on your calculator because that allows you to put in any base. However, most calculators do not have that feature, and that's why you need to know how to convert bases. This is called the change of base formula. Okay, we're doing 3 to 49 odds. Number 3, we want to use the properties. This is subtraction. So it would be log of 6 divided by 2, which would be natural log of 3. I believe that matches to letter B. On 5, you could take the number out front of the logarithm, put it up as an exponent. Natural log of 2 to the 6. 2 to the 5th is 32. 2 to the 6th would be 64. So I believe that would match letter A. That's for 3 and 5, you're matching. Here they give you some values of log 4 and log 12, and they want you to use them to find log of 3. Well, what is 3? Is 3 12 divided by 4? Is that still 3? Could it be log of the top minus the log of the bottom using this middle property here? And I know these values. You use 1.079 minus the 0.602. And I think you would get about 0.477. How could I get a 16 using these numbers? Well, maybe I could do 4 to the 2nd. 4 to the 2nd is 16. I could pull the 2 out front using this property of logarithm. The bottom one here allows me to pull the exponent out front. And so I have 2 times the log of 4. 2 times 0.602, which is 1.204, I believe. So you're using these values and trying to match it into one of the formulas so that you can evaluate it. On 15 and 17, they want us to expand. This would be log of 4 plus log of x. Why? Because this is the log of a times b. And the log of a times b is log a plus log b. So this is log 4 plus log x. This one I could break up in 17, log 3 plus log of x to the 4th. There's one thing left to do, and that's to pull this exponent out front using my properties. And this would be the expansion for number 17. 23, you have things multiplied. I'll just put the base 7 in at the end. Log 5 plus log of x to the 3rd plus log of y plus log of z to the 3rd. So I would have log 5 plus 3 log x, because I can pull the exponent out front, plus log of y plus 3 log z, because again I could pull the exponent out front. So that would be the expansion for 23. And I'm sorry, it's z squared. So this should be z squared So the number in front here, if you pull the 2 out, would be 2 log z.